All right, my physical scientists. So we have been learning all about the periodic table and how elements on the periodic table are important to different aspects of our lives. And you're probably familiar with a number of these elements, and you're also probably familiar with some molecules that different elements create. For example, you all know about water, and you, I think, probably know the scientific name for water, or H2O. What this means is that it's made of hydrogen and oxygen combined together as a compound. And we can also call it a molecule because it is multiple atoms stuck together. So H2O actually means that we have an H, a hydrogen molecule, and we actually have two of them because there's this little 2 right after it. So I have 2 hydrogen molecules and then 1 oxygen molecule, and they are stuck together. And they're stuck together with chemical bonds. Chemical bonds, just like we've been learning about this unit. It's their electrons that allow them to stick together as chemical bonds. And they are a compound or a molecule. Both words work. Compound means combo of 2 or more elements as a molecule. You can have molecules that are made of just one type of element. For example, the molecule O2 is just oxygen, and it's an oxygen atom stuck to an oxygen atom, and they're stuck together. I think they might be stuck together in a double bond. We're not going to worry about the types of bonds, but this is a molecule made of just oxygen. So today we're going to be looking at chemical reactions. You've already seen some different pieces of evidence of chemical reactions. And so we're going to be working on ways to represent chemical reactions using an interesting model. So we're going to look at chemical reactions using a model to really try to understand what is happening in a chemical reaction. So from the videos you saw, what is going on at an atom element level. And so to do that, we're going to use some weird not elements. They are made of course, matter. But we're going to use some nuts and bolts. So this is a bolt. It doesn't have a pointy part, that's why it's not called a screw. And this is a long bolt. So we're going to use some long bolts. Use the name LB to stand for long bolt. SB will be the logically short bolt. Again, it's a bolt, it doesn't have a pointy part. And then I have these things called nuts. I've got hex nuts. Notice how it's like a hexagon. The picture right here of what I'm going to draw my pictures as is it standing on its side. So then it just looks like a line. But it's a hex nut. And then I have this other type that's called a wing nut because it looks like it has wings. So these are going to be our pretend atoms. They're going to be atoms, and we're going to look at how they stick together. So first, I'm going to take a moment and review some compound making with you. And ideally, I'd have you be doing this with your hands, but in distance learning, that doesn't quite work out for us. So we're going to make the molecules drawn below and then answer the molecule formula review questions, these guys. So first off, I'm going to make SBW, and it looks like this. So that means that I'm going to take a short bolt, and W means wing nut, and combine them together. Okay, so that's SB and W. And then just W would be this. So notice that this SBW is stuck together. When it's just W, it's all by itself. So that's this first one. Then if I want to make this next one, LBW2, that means that I'm going to take a long bolt, and I'm going to need to use 2 wing nuts, because notice that there's a little 2 that comes after the W, and in our picture we can see that there's 2 wing nuts on it. And again, I'm putting it together so that the wing nut is stuck to the long bolt, because they're written together. And so that means that it's a molecule or a compound, and it's all stuck together. So we've got a long bolt and two wing nuts. And that's this compound. So this is a compound. It's maybe kind of similar to like water because there's two of one atom and one of the other. Then I'm going to make a short bolt hex nut. That means that it's actually hex nut 2. So I'm going to put on 2 hex nuts on my short bolt. And again, that little 2 after our hex nut, HX, little 2, tells me that there's 2 hex nuts stuck on our short bolt. Ta-da! So go ahead and take a moment to try answering these questions. What is representing an atom in this model of elements combining together? What is representing the molecule? So for example, I might say an atom, well that's just the individual bolt or nut. Here we have a short bolt, that would be representing an atom. And a molecule, well that would be the stuck together bolt and nuts. So that would be my molecule. So I describe that. And then how does the way the nuts and bolts are connected relate to how the formula is written? And especially looking at this situation could be really helpful for thinking that through. And then our last question is, what would be different about SBHX2 than SBHX? What does this 2 tell us that's different from this one? So take a moment and answer these questions on your Notability file and pause the video. Excellent. Okay, so then we're going to use these same nuts and bolts to do some chemical reactions and to actually simulate what happens in a chemical reaction. And so first we're going to follow these directions, but I want to talk to you a little bit about some chemistry words about chemical reactions. So the beginning stuff in a chemical reaction, it's called the reactants. It's also written right here in a worksheet. It's the starting molecule. So the stuff we start with, it's called the reactants. It's going to react together. And the stuff that we end up with is called the products. It's the molecules we have at the end. So for this activity, we're going to try doing some chemical reactions with our nuts and bolts. So I'm going to start with my starting molecules. I need a long bolt wing nut right here and a short bolt hex nut like that. And I'm going to go ahead and write that down that I've got. I'm going to write it down in chemical formula. So it's a long bolt LB wing nut. And then I have a short bolt SB. Notice the S is capital, the B is lowercase. And then a hex nut HX. So then, these are my reactants. They're what we start with here in our chemical reaction. What we're going to look at is what happens next. So our long bolt and short nut get mixed up together in our chemical reaction, and we get these products. And so notice that on the products, the hex nut has now gone to the long bolt. So I'm going to have it switch. Hex nut goes onto the long bolt. Ta-da! And the wing nut is now on the short bolt. So it's just like they traded places. And so now my chemical formula, I have the long bolt LB and the hex nut HX. And then I have the short bolt SB and the wing nut. So notice that I have the exact same stuff that I started with. It's just been rearranged a little bit. So let's try another one, another chemical reaction here. So take a moment and think about how you would build this molecule out of my nuts and bolts. What nuts and bolts would you need? And think about how they are connected together. And then take a moment and think about what will the name be for this molecule in this weird model we have. So here I've built my weird molecule. It has a long bolt and a wing nut. So I've got a long bolt and a wing nut. And then there's actually 2 wing nuts. So I'm going to put a 2 after the wing nut. And then our chemical reaction happens. And this reaction is a decomposition reaction, or a reaction where the stuff falls apart. The molecule actually has fallen apart into its component parts. I've got my long bolt, I've got a wing nut and a wing nut. So I'm going to draw that. Oh, Miss Getz, you did it wrong. This is a short bolt, guys. Long bolt, long bolt. It falls apart into a long bolt and 2 wing nuts. So again, I'm going to draw my long bolt. And the wing nut looks like that. So notice I'm drawing it in picture and then I'm drawing it in chemical formula way. Okay, so maybe we'll try one more together and I'll see if I can manage to not mess this one up. Oh, good. So we start with our long bolt and our short bolt. So I have a long bolt, LB, a short bolt, SB, and then 2 wing nuts, wing nut, wing nut. And notice that they're not connected together. Nothing is connected together to start. And then I'm going to go ahead and have my chemical reaction happen. And notice that they all get connected together. So that means that I'm going to take my wing nuts and attach them together. And then here's a kind of weird way that this model works. My wing nuts are actually going to hold my short bolt to my long bolt, which is kind of hard to do, but you're missing out on the hard to do part because you're not here in person, but that's okay. So notice now they're all stuck together. So I'm going to draw what my products look like. The reactants were all separate. Now that they're the product, the thing that is produced in the chemical reaction, I'm going to go ahead and draw what that looks like. So I've got my long bolt. Whoop. I've got my short bolt, and notice the short bolt has a colored in end. Whoop. And then I've got a wing nut connecting them, and this other wing nut. It's not a very good wing nut. But I'm drawing what the picture looks like, and I've got my chemical formula. So how about you take a moment and try drawing what you think this would look like. Go ahead and pause the video. What will that look like? See if you can draw the picture representation, imagining maybe what it would look like to have these all connected together. And so I'm building, here's my short bolt and 2 hex nuts. So I've got a short bolt and 2 hex nuts. And then I've got a short bolt and a wing nut. So I'm going to draw that, short bolt, and wing nut. And I have this wing nut backwards from the other ones, but that's okay. Then they go in the chemical reaction and things get combined a little bit differently. So notice that now that 2 hex nuts are distributed on both of my short bolts, and the wing nut is connecting the 2 short bolts together. So we've got our 2 short bolts connected together and our wing nut joining them together. So I've got a short bolt and a hex nut and a wing nut, and then another hex nut. So that means there's actually 2 hex nuts. So I'm going to put a little 2 next to this hex nut. HX stands for the hex nut, and I've got 2 of them. And then there's 2 short bolts, and so I'm going to put a little 2 next to those. Awesome. So take a moment and try drawing what you think the chemical formula will be like for this. I'll take a moment and build it for you. It looks a little different than what I have right now. And then you can figure out whatever you want it to produce, whatever products you want this last chemical reaction to make. So we're going to start out. Notice that we have oh man, it's really hard to get these big atoms, big molecules to stick together. Whew, I did it. So my wing nut points the wrong way. I hope you don't mind. So I've got a short bolt, SB. I've got a hex nut, HX. And I've actually got 2 of those hex nuts, so that's going to get a 2 after it. Then I've got a wing nut, just 1 of them, and I've got a long bolt, SB, LB. That is one really long molecule. So it's got a lot going on in this molecule, and you can figure out what you want the products to be. But remember that they have to be a combination of all the things we started with. So here we're suggesting there's 2 of them, so maybe you make something that looks like this, where our wing nut goes away, and our 2 bolts are now stuck together. Oh no. Well, maybe my bolt is separate. So the long bolt is separate, and then the short bolt gets the wing nut, making my life a little easier. You can decide whatever you want these products to be, and then take a moment to go ahead and answer these last questions about what physically takes place when our reaction happens with the nuts and bolts. My hands do the stuff, right? So it's not quite the same as real atoms, but think about what this means is happening in a chemical reaction with real atoms. And then come up with at least one way that nuts and bolts are similar to real atoms, and then one way that nuts and bolts are different than real atoms. Because again, this is just a model to help us understand what happens in a chemical reaction. And then go ahead and move on to the next video to help guide you through part 2.